Hi, this is Professor Collins. Today I'm going to provide you with some information to use when we're doing the pH determination lab. First, we need to talk about solutions. What is a solution? A solution has two parts. First of all, it can be between the same phases, gases and gases, liquids and liquids, or it could be a gas-liquid solution, like a can of club soda. But it contains two parts. One is the solute, and by definition, that's the smaller of the two parts. Typically, it's a crystalline if you're making up a aqueous solution. And you also have to have a solvent. The solute and the solvent equal the solution. For example, let's make up a simple solution of salt water, like seawater. You have a solute in form of NaCl. That's the solute, and the solvent is water. You mix those two together, and the crystalline sodium chloride ionizes to form sodium cations and chlorine anions, and it's surrounded by the water molecules. In chemistry, we use a certain unit to measure the concentration of a solution. How much solute do you have in a given solvent? And in chemistry, we use the term molarity. Molarity is defined as the moles of the number of moles of solute into the amount of volume liters of solution. Let's calculate a solution concentration using this example. 5 grams of sodium chloride is my solute, and 100 milliliters of water is my solvent. What is the concentration of my solution? Well, I need to convert grams of sodium chloride to moles of sodium chloride. I'll have my numerator. 5 divided by the molar mass of sodium chloride, which is 23 for sodium and 35.5 for chlorine, to get 58.5 grams per mole. When you divide 5 by 58.5, you get 0.0855 moles of sodium chloride. So the molarity, or the concentration of this solution, is the number of moles divided by the volume in liters. You can see I converted 100 milliliters simply by moving the decimal over 3 places to turn it into 0.100 liters. So it turns out the concentration of this example is 0.855 moles per liter. Next, we want to talk about pH. What is pH? pH is a measurement of how acidic a solution is. We know that we learned in science classes that pH scale runs from 0 to 14. 0 is the acidic range, 14 is the basic range. The pH of 7 is what we use to represent pure water. The pH can be calculated using this equation, the minus the log of the hydrogen ion concentration. The brackets indicate the concentration in molarity, what we just discussed, moles per liter. Moles solute per liter solution. Water ionizes into the hydrogen ion solution, which represents the acid, and the hydroxide ion, which represents the base. You can also look at this reaction written this way, where 2 molecules of water produce 1 molecule of H3O+. That's called the hydronium ion. That's essentially the hydrogen ion plus water plus hydroxide. Aqueous acids also ionize in water. HCl, which we consider one of the strong acids, will ionize to form hydrogen ions plus chloride ions. Now, I indicate this with 4 arrows just to make the point that this is a strong acid, so about 99.9% of it will ionize into these two ions in solution. Whereas the next acid, this is acetic acid, hydrogen with our polyatomic acetate, it's called acetic acid. It's one of the weak acids, and so it only ionizes about 1% into hydrogen ion plus the acetate anion. Well, let's calculate a pH. If we use pure water, when the hydrogen ion concentration is equal to 1 times 10 to the minus 7 moles per liter. We plug 1 times 10 to the minus 7 into this equation, and we get a pH equal to 7. That's water at its neutral point. Let's look at another example, and I'm going to use my calculator to show you how to get the right answer. What if I want to go the other way in using that equation? pH is equal to minus the log of the hydrogen ion concentration. What if I'm given the pH and I want to find the hydrogen ion concentration? I rearrange the equation to solve for H plus in brackets, that's the hydrogen ion concentration. That's equal to the inverse log of 10 to the minus pH value. If I'm given a pH of 2.5, 10 to the minus 2.5, this is how you would do using your calculator. You would hit the second function button, log, where it has 10 to the x above it, and you see the box flashing, and here you would enter minus 2.5. The answer is the hydrogen ion concentration is equal to 0.00316 in moles per liter. Moles per liter. Let's look at another example. What's the pH of a solution if the hydrogen ion concentration is 3.5 times 10 to the minus 10? With your calculator, you would hit the inverse log of the hydrogen ion concentration, which is 3.5. I'm going to use my shortcut key, 10 to the minus 10, close brackets, and that equals 9.46. The pH of this solution is equal to 9.46. Let's do one more. And again, we'll do the opposite one. If we're given a pH of 12.2, what is the hydrogen ion concentration? Well, it's the hydrogen ion concentration is equal to the inverse log to the minus pH value. The inverse log is, hit the second key if you're using a TI-84. The log function, you get 10 with a blinking box above it where you would enter minus 12.2, because I said the pH was 12.2. This is equal to 6.31 times 10 to the minus 13. So in this lab demonstration, the virtual lab experiment, you're going to calculate pHs, and you're going to measure pHs from what's in the video, but then you're also going to calculate hydrogen ion concentrations. So recall, the pH is equal to minus the log of the hydrogen ion concentration. That's what represents how acidic something is. And that's in units of molarity, moles per liter. Now, the inverse is true. We can calculate the hydrogen ion concentration if we know the pH of a solution by taking the inverse function of the minus pH value. So if you're given the hydrogen ion concentration, you can find the pH. If you're given the pH number, for example, a problem, you can calculate the hydrogen ion concentration using these two equations. This ends my lecture for the virtual lab experiment for pH measurements.